All right, we're going to record here. We're going to talk a little bit about section 12.1, double integrals over rectangles. Okay, so how many remember, how many like Oreo cookies? I'm going to, a little analogy here. How many of you like Oreo cookies? Usually a lot of students do. Okay, John does. All right, Ryan does, and all right, Eric, love them. I hear you. How many like double stuffed Oreo cookies? Even more. How many have heard of the double, what's it called? Double stuffed Oreo cookies where they have twice the filling? Okay. Ryan says it's better. Okay, John likes it too. Great. All right. Well, you know, that's how I think of integrals. You're used to doing single integrals, but when we want to find the area underneath the surface, Eric. Well, all right. When you're finding, okay, so let me show you here what I mean here. So this is what you're used to. You're used to finding, you're used to finding the area underneath the curve. And the Riemann, you add up the rectangles, the areas of the rectangles, that gets your Riemann sum, and the Riemann sum turns into an integral. And that's, you're finding the area under a function of x. Okay, how do you recall that from a while back in Calculus 1? You learned that. All right, good. So okay, well, if we have a function of x and y, okay, that function is a surface. It's a surface in three-dimensional space. So now we're interested, we can't find the area under a surface. What would that be? We have to find what under a surface? We don't find the area under a surface. We find what? We find that, now let me see, did I lose the book here? Hold on. Is the book showing or not showing for you? Let me get it back here. I don't know why it does that. Okay, let's see, is it, come on. Okay, there was an answer. Okay, so there was a chat here. Hold on. Volume, that's right, Ryan. So if we have a surface, which would be represented by a function of x and y, we want to find the volume under that surface. And to do so, really, hold on here. To do so, it's not that hard. It's not that hard. You know, here in figure 2, you have a surface, a function of x and y, and you have some region below the surface. And what are you going to do? What are you going to do? Well, you're going to divide that region, you're going to partition that region up into rectangles, and you're going to create a bunch of bricks, a bunch of what we call parallelepipeds or bricks. Okay, so you take the region R, divide it up into rectangles, and then every rectangle, okay, every rectangle here in figure 4 has some, you know, volume associated with it, and it's easier just to show you the actual end picture, I think. Here's the end picture right here, there in figure 5. See there? I mean, that would work, right? If you want to find if you want to approximate the area under surface, couldn't we, I mean, can we find the volumes of all those bricks there, of each of those bricks? What's the volume of a brick equal to? That's right, Ryan. Length times width times height. So we can find the volumes of each of these bricks and add up the volumes, and we would get an approximation to the volume under the surface. So here, is what you would do. But it involves a double Riemann sum, because you have to move your points around that region R in the XY plane. So you're going to need to have two Riemann sums in order to do that. And of course, if I want to kind of finish up here, because what would that Riemann sum translate into? Well, if you were to take the limit of the Riemann sum, if you were to take its limit, let n and m go to infinity, you would have a double integral over a region. So this is what we're going to be learning. We're going to learn how to find actually the exact volumes underneath the surface over some region R in the XY plane. And that's what we're going to do when we return from break. We're going to learn about iterated integrals and double integrals, how to compute them. It's really not that hard. But for now, we have to be content in section 4.1 with approximating the area under the surface. So example 1 talks about estimating the volume under a solid, okay, below a paraboloid. Divide the region R into 4 equal squares. So all you need to do is the paraboloid, well, the region they're talking about is 0 by 2 by 0 by 2. That means it's just the region where that encompasses well, they have a figure here. This is what the region right here in the XY plane. X goes from 0 to 2, Y goes from 0 to 2. And they draw 4 bricks, okay, and they're going to add up the volumes of those bricks in figure 7 to approximate the surface. That's what they're going to do. Okay, and all you have is, of course, the height of the bricks is determined by the function, by the value of your function. And in this problem, they're going to choose the sample points to be the upper right corners. So they compute the function values, 4 function values, and multiply by the area.
We can no longer see your screen, Professor.
Sorry? You can't see the...
We can no... Yeah.
Hold on. Let me bring it back. One moment, everybody. One moment. I got to bring it back. Hold on. Thank you. Let me bring it back here. So I might go over a few minutes. I didn't mean to, but I don't know why it does that. I mean, we all, this is like, we use this book. It shouldn't be, I don't know why it does that. But let me bring it back here. Okay, thank you. So, okay, so, okay, so you see they're choosing the sample points to be the upper right corners of each of the squares. Thank you for alerting me about that. Thank you. And they just add up the volumes. They take the region, the area of the region, of each little region, base times height, and multiply it by the height, which is determined by the function values. So what they're doing is the area of each little region is going to be 1, based on figure 6. And then the heights of the region are, f of 1, 1, f of 1, 2, f of 2, 1, and f of 2, 2. Again, they want to use the upper right corners of each square. And so they approximate the volume as 34. That's the approximate volume here. And so I'll probably have you do a couple problems, just maybe 2 or 3 of this kind, just so that you're comfortable with this. It's really important to be comfortable with it, so that then when we talk about more about chapter 12 when you return from break, you'll be good to go. Are there any Any questions on that? Let me see. All right, so class, I think we're good here, and I do thank you for staying a few extra minutes. I hope you have good luck on your remedial problems and submitting your exam work. Thank you for a very nice class tonight, everyone. I appreciate it, and I hope you have a nice break next week, and you have some time to relax. So that's good. That's good. And I'm seeing 2 students after class here, just for a little bit. But basically, we're done for the evening. And thank you so much and if you have any questions, feel free to stay a little bit. And I hope I got I'm back in the session, so hopefully everybody can hear me okay. Is everybody good? Okay, good, good. All right, wonderful, everyone, wonderful. Well, have a nice break, and I really enjoy this class a lot. I enjoy all of you in my class. I'll miss you. I'll miss you, but I'll be seeing you, right? I'll be seeing you after next week, right? So have a nice break, Eric. Thank you, and good luck on your MATLAB. I know you're working on that a little too. Thank you, Robin. Thank you, Ryan. Good luck with your groups. Thank you, Naima. Have a good one. Thank you, John. Have a nice break. Appreciate it. Thank you, Marvelous. Have a good one. Thank you, Eric. Okay. All right. Jamal's here, and let me see. Let me see. Where's the other student that's supposed to be here? Hold on. Okay. So Jamal, of course, I'll talk with you first, I guess. But I thought this other student, his issue was a little, less. Just to take a little less time. But I don't see the student in the room at all. So hopefully he'll come back. So I'll tell you what. Let Jamal. You know where that course room is that I showed you all in. Okay, why don't you go ahead there, and I will. I'll see you there in a moment. Okay. I got your email, by the way. I got your email. Okay, very good, very good.